This is our power ultrasound technology, and this technology uses sound waves in a liquid medium. And the beauty of this technology is it can be utilised in a wide range of applications. Power ultrasound can be used for defoaming applications, heat mass transfer applications, and it can be even used for improving extraction. The way the technology actually works is we will have a signal generator, and the electrical signal will be passed through to the transducer. This converts the electrical energy into sound waves, which can then be propagated into the liquid media via the sonotrodes. These sonotrodes come in a range of different shapes and sizes. Here's a more flat sonotrode, and we also have smaller but longer diameter sonotrodes with curved edges depending on the applications we're looking at. This can be small scale operations, but can also be scaled to much larger commercial operations. It is used in the pharmaceutical industry for a wide range of applications. This technology is cold plasma. If you've never heard of cold plasma before, it's the fourth state of matter where a gas is converted into a load of charged reactive species where it can be used for antimicrobial purposes. We've been using this prototype system to understand the inactivation on continuous conveyor belts. We've been working with the University of Liverpool in trying to find applications for cold atmospheric plasma. This is because at the moment it's not commercially there, but there are still some applications that are starting to emerge. So how do we generate plasma? So the way that we generate plasma is by applying electricity to a gas that we're trying to excite and convert into chemical reactive species. Here we have two sets of electrodes that we're trying to sandwich together between quartz plates. And just on the edge here is where the plasma discharge will form, and all the reactive species have antimicrobial properties that can cause inactivation of bacteria. We're exploring how to optimise this technology to get real commercial application. This is our ultraviolet light tunnel. This operates in the spectrum of the UVC band, which is from 200 to 280 nanometers. Most of the lights that are in here are at 254 nanometers, and at that wavelength absorbs into the bacteria's DNA and inactivates it. UVC has a wide range of applications from fresh produce, baked goods, surface decontamination, shelf life extension, through to on-the-farm treatments to extend the shelf life of fresh produce. People are also trying to use this for high care, low care transfer tunnels where you need to get items into the factory and you don't want to start spraying and misting it with chemicals. It's a very versatile technology that people use for surface decontamination applications. Over here we have a sensor that we will use, and this sensor is used for monitoring the dose. So we will monitor the dose of a system where a manufacturer has validated that dose to deliver a certain level of inactivation, and then they use these dose sensors to verify that their system is always delivering over that threshold dose. The way the lamps work is we have in our tunnel 2 cassettes above and 2 cassettes below. So this is the cassette above and this is the cassette below, and in each cassette we have 4 UVC low pressure lamps, a total of 16. This is another UVC treatment system, but this one is for liquids. Primarily high transmissive liquids where the UVC can penetrate through the liquids and decontaminate it. The water will flow in through the start and it will pass over the UVC lamp where it will decontaminate all the bacteria before it will go off into the production run. This is commonly used for treating water being used in soft beverage manufacturing or water you want to guarantee the safety of as an ingredient for food production. Very reliable, very well researched, and there's a lot of information and data out there on this technology. The way they monitor the dose on these systems is they will have an intensity meter and they will monitor the intensity of the UVC light as the liquid's flowing over it, so they know they're achieving the resident dose as the water's passing through it.